Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Binomial. That special channel created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. I wish to sincerely appreciate you for staying tuned and being loyal subscribers. Thanks and God bless. Today, we are going to wrap up the topic binomial expansion, which we have been treating for the past 3 videos or thereabout. In the first video, we looked at the concept of binomial expansion with emphasis on the Pascal's triangle. And the next video that followed that, we looked at the binomial expansion formula, both the form that can be generally applied to any value of n and other which has restriction. And in the third video, which is just the last video before this, we have the evaluation of numerical values using the binomial expansion idea. Today we are just going deeper by looking at some special scenarios whereby we are asked to find the kth term in an expansion and then the coefficient of the specific term. How do you go by this? We have the formulas on the board. To start with, if you are asked to find the kth term in an expansion, you don't necessarily have to do the whole expansion before picking the required term. Of course, you'll be right, but that will amount to waste of precious time in an examination. Hence, the need to apply this formula Tk, which is the kth term, is given as n combination k minus 1, then x raised to power n minus k plus 1, y power k minus 1. That's one hand. On the other hand, you might be required to find the coefficient of a specific term in a given expansion. Once again, you don't necessarily to do the full expansion, particularly when the n is very large. What you need to do is to use this particular formula to pinpoint the exact coefficient required. And these two will be the essence of our video today. Stay tuned and have fun. Let's take our very first question here, in which we are required to find the coefficient, find the sixth term in the expansion of 5 plus 2 plus 5x to the power of 11. Look at this now. This is power 11. We don't have to go all the way out to actually expand, since we are interested in only getting the sixth term. So we're using this formula by saying that Tk is what? N combination k minus 1 and x to the power of n minus k plus 1, y to the power of k minus 1. So our parameters will be as follows. N is 11, k is 6, and that does it. So we're going to say T6, which is the sixth term, is 11 combination 6, k6 minus 1 is 5, x is 2 in this case, that's 2 power 11 minus 6 plus 1, and y actually 5x to the power of 5, which is 6 minus 1. So this gives us 11 combination 5, everything there. We give us everything here. We have 11 combination 5, then 2, 11 minus 6 plus 1, that is 6 still. That's still 6. Then we have 5 to the power of 5 and x to the power of 5 well. So that's simplifying this particular formula. Again, the formula is Tk equals n combination k minus 1, then x to the power of n minus k plus 1, then y to the power k minus 1. And we said that our n is 11, obviously for the question, and k is 6, which is the term we are desirous of getting. So swapping them in, we're going to have 11 combination k is 6 minus 1, 5, 2 power 11 minus 6 plus 1. Then y, of course, is the entire 5x raised power k minus 1, which is 6 minus 1, 5. So, and we arrive there. Now, 2 to the power 11 minus 6 is is 5, plus 1 is 6. Then 5, open this bracket, 5 power 5 and x power 5. When you compute everything there, you're going to have as your answer 924. That's 92,400,000 really x to the power of 5. That's exactly, it's going to be the 6th time that we need. So we don't need the entire full expansion. So the calculator just get level combination 5, 2 to the power 6 is 64, and 5 power 5 is 3125. And you get that as your 6th term of this expansion, which I believe is quite explicit. Okay, so let's now take another question on these questions. So, there we are required to obtain the coefficient of x power 7 in the expansion of 3 minus 2x power 10. Again, you don't have to do the full expansion to get the coefficient of just this x power 7. You don't have to do that. Rather, let's apply this formula again. So here in this case, using n convention k, y power n minus k, then we have x power k really. Okay? X power 7 is increased. That means 7 is k and n is 10. So applying that, I'm going to have 10 combination 7. So we have then we have 3 root power 10 minus 7. Then x there is going to be 2x root power, sorry, minus 2x root power. So it is done in such a way that x must have 7 in the power eventually. That's why I didn't bring it here. So x power 7. So when you do this, you're going to have 10 combination 7, then times 3 power 3, and then minus 2 to the power of 7, then x power 7, opening the bracket. That's minus 2 power 7, then x power 7. So when you do that, your calculator now just compute 10 combination 7 times this 27, then times minus 128. You're going to arrive at minus 414,720. That's actually the coefficient of x power 7. So what we need is just this, and that's the coefficient. So it's minus 414,720. So with that, we come to the end of the video, our lesson today, which has been on how to get specific terms and coefficients of a given term in an expansion of x plus y to the power of n. It might not be that easy for you as a first timer, but trust me, when you lay your hand on questions over and over, you get more and more proficient. Don't forget, mathematics is about practice. The more you practice, the better you become. That's all for us today. Thanks so much for staying tuned, and God bless.